Greetings, 8th graders. This is Mr. Rogers. I'm just going to give you a quick overview of what you're doing today since I'm not here and Miss Clausen is. So what you see on the screen right now is actually a paper version of what you have in your ISN. This would be page 12 of your ISN. And I think I probably gave you a little bit of a hint at this yesterday, but just to make sure that everyone's on the same page, what we're actually doing is we're taking the hanging mobiles that are up on the ceiling right now, all the planets that we scaled down, and we're going to take that scaling to another level, because now we have the right size. What we really want to see next is how far apart should these really be if they really were this size. So we're going to scale distance as well as diameters. So that's what you see on this page. You see real distances of each planet in kilometers. So Mercury really is 57,900,000 kilometers away from the sun. What I'm curious about is if the sun was in the classroom, then how far away should we set our little hanging mobile of Mercury? Would it be like on the edge of the room here? Would it be out in the hallway? Would it be over in Miss Beaniac's room? So that's the name of the game today. So you might notice that right here, you are going to calculate the scale by taking the real distance from the sun of each of these planets. So even though you were only in charge of one of these earlier, you're going to figure out all of the distances today. You're going to take each distance and you divide it by 2300. And that will tell you your distance in centimeters. But you'll notice here where it says next. And it really pays to read through this section, because it's going to tell you something important. It's going to tell you how you're going to notice that you're going to get a really insanely big answer. So you need to convert that to something simpler. So you're going to take your answer from here and you're going to move the decimal 5 places to the left to change the scale into kilometers. And then you'll write that number down here. So this is how far away it would be in real life, but in a distance of kilometers. And so if this overview makes sense, you're probably itching to get in there and start doing your calculations right now. If you need to see one of these like for yourself to kind of understand what this looks like, then I would recommend that you actually click on this link in your ISN, because it'll give you another quick video tutorial by me where we actually do the first one together, Mercury, and you can see what the actual distance of Mercury would be. So that's there to kind of help you out too. And Miss Clausen will be able to help you out with further questions. But really, you want to watch that video first before you come to her with questions, because that could clear everything up for you in just a matter of a couple minutes. So that's phase 1. And you'll see here it tells you what you're going to do next. It says use a protractor on the 3 map sheets provided to draw out the orbits. So if I take this out and bring this in, this is the compass, of course, that I'm talking about. You've used these before, and we'll use them again. And this is a map that we can use for the inner planets. So this map will work for Mercury, Venus, Earth, and Mars. Once we get beyond Mars, you can't fit the next one on. So we actually have several maps so that you can fit everything in eventually. So you can see here's the school right here. Here's the Bob Cross Nature Park, the nature trail. You might recognize a few other landmarks. I see, let's see, where would Mississippi Heights be? I think it's going to be over by the cemetery area, if I remember right. I think, would it be right around here? I don't know. You folks that are from Mississippi Heights can tell us the best. Here, of course, is Highway 10. So what you're going to do to figure out how big to make your circle to represent where Mercury would be is you just need to take one more step. You're going to take the planet distance that you calculated back here, which would be this number. You're going to take that and you're going to convert it into a map scale. In this case, you're going to divide it by 0.2. That will tell you the radius of the planet's orbit. So whatever answer pops out, you just need to set your compass to that distance. Set this on top of the school, put your pencil in the hole, and draw your circle around, okay? Again, I have a video tutorial in case you're not exactly sure how these compasses work, and that can kind of help you with that stage right there. And you'll actually see me do Mercury all the way from taking it here, dividing it by 0.2, figuring out the radius, drawing it on here. So you at least have one demonstrated for you. Compasses, Miss Clausen will show you where those are. Once you get done with this one, you get out past Mars, then you can jump in with the second map, which is printed in a different color, and this map will be good for Jupiter, Saturn, Uranus, and Neptune. So you can use those. Once you get past Neptune, oh, and I guess I should backtrack real quickly. You might notice on this map that it's a larger area, so we're zoomed out a little bit further, and that means that the number here changes slightly. So when you take your Jupiter number, for example, you're not going to divide it by the old number on the green sheet, like 0.2. You're going to divide it by 3.5, and then that will get you the radius out here. So when you change maps, you need to change your conversion factor. Once you get done with those 4 planets, then there's a blue map that'll work for the dwarf planets. Pluto and Eris are the last 2. And again, just notice that the conversion factor changes. So by the time you're done, you'll have 3 maps, each one with a different color. And then the last thing, back in your digital ISN, you'll notice there's a spot for you to take a picture and place each of the maps so that you've got them digitized and so that I can see them pretty easily too. Once you have them digitized and in there, then you can discard the paper copies. You're not going to really need them anymore. Trying to think of anything else. Oh, I suppose this might be helpful to you. I would recommend that you work with a partner. And I'm going to let you choose your partner. Unless Ms. Clausen says otherwise, she may have a reason why she may want to override that and have you guys use a selected partner. But if it's okay with her, I think you can partner up with another person in the room, because I think two brains are better than one, and it'll make the work half as difficult, and I think it'll go twice as fast and twice as easy. So with that in mind, then work on this in pairs. Together you can complete your 3 maps, digitize them, and then you'll be able to show me this when I'm back on Friday. And if you get done early and you have a little bit of spare time, I would recommend you finish up your caricatures on page 8 of your ISN if you don't have that done, or if you wanted to work on your mini mind map, your Jovian, terrestrial, and dwarf planet mini mind map, you could do that as well, because that's page 11 in your ISN. And both of those assignments are due sometime today. You could upload them today, upload them tonight, but they need to be uploaded at some point today in order to get full credit. So it's a busy day, and hopefully you get some big aha from doing these 3 maps. I think you will. At any rate, you'll let me know on Friday, tomorrow, when I'm back, and you can let me know if there's something you've discovered by doing this. So good luck, everybody. See you on Friday.